This is the Pn4025 Pedagogical Podcast by Kim Butler, Michael Murphy, Michael Sullivan, and Patrick Daly. So, today, what we are going to be learning about is finding the true shape of a lamina using the two auxiliary views. So, now we'll go down to the first slide, and here we see a lamina in plan and elevation. As you can see, in elevation is A, B, C, and that is directly sent down to plan, and that is A, B, and C again. So just to reinforce this, we're going to show you a quick video of a planes board, and here we see a lamina in at the start of the video in elevation, and that'll be directed back onto the vertical plane, and then as the camera angle moves up, we'll see the lamina in plan, and this will be directed down here onto the horizontal plane. Now these planes boards are very good as students can come up to the board and see from themselves, and they'll be able to draw on the lamina, and they'll be able to draw on the vertical plane using the whiteboard marker, and this is a great educational tool. So we'll move down now. So in order to develop the true shape of the lamina, we need to first get an edge view. So what we're first going to do is we draw a level line out from A, and where it hits BC, we're going to call this point X. So we're going to drop this line down to plan here, and where it hits BC, we're going to call it X again. And since the line came from A in elevation, it's going to come from A in plan as well. So once we have that line at A here, that is going to be a true length. So now we can use this, the next slide, we can use this true length, and we're going to look down along this true length from A here, and we're going to extend our lines C and B and A. So those three lines there are going to be parallel, and in order to get the edge, to get an edge view, we have to use an auxiliary. So we have our X1 and Y1, so this is going to be our first auxiliary. And then, so now what we must do after this now is get the heights. So to find the heights, we have a quick question here. If you like, if you're teaching this to a class, you can pause the video here and ask the class and engage with them. So how many views do you go back when looking for the heights of an auxiliary? So do we go back for here, do we go back one view to plan? Do we go back two views to elevation? Or do we go back three views to if we're using the second auxiliary? So the answer is two views. So when finding the heights for an auxiliary, you always go back two views. So as you can see here for C, what we've gone and done is, so we trace our line from the auxiliary back to plan up to elevation, because it's two views from here to here, 1, 2. So we'll put our compass on X, Y, and we'll extend it out to C, and then we'll follow our line back up to the auxiliary. We'll put our compass down here, and we'll mark it off C, and we'll repeat this process for A and B. So then moving on, you can pause the video here again, talk to the class and engage. So what is the line CAB called? So this line CAB here, it was mentioned in the start of the video. So what is this line called? Is it a true shape? Is it a true length? Or is it an edge view? So the answer is CAB is an edge view. And to find the true length, to find the true shape of the lamina, we first have to find the true length in order to find the edge view. So there's multiple steps within this problem. So now our next protocol is to bring our lines straight down. So we want to, because what we're doing now is we're looking at the edge view from here. So we're looking down. Imagine this is an arrow here. So we're looking down into CAB, and we're going to bring our lines straight down. So they're going to be perpendicular to this edge view line here. So we brought our lines straight down, and now what we have to do is use our second auxiliary. So we're going to draw our second auxiliary line. So it's going to be X2, Y2. And once again, how many views do we go back to find the heights for an auxiliary? So we're going to go back one view to the first auxiliary, and we're going to go back to plan. Now, in order to find the heights from plan, what sort of line do we use? Where are we going to measure our heights from? So what we're going to do is use a thing called a datum line. So why is a datum line used? So a datum line here is used as if we were to use a normal X1, Y1. from going back two views, the the length of the lines would be too big, and so the drawing would be off the page. Your true shape would be down here, which would be no good for it. So we use a datum line. So we're going to put a datum line perpendicular to these construction lines here, and it will be parallel to x1, y1, the first auxiliary, as we're going back two views. So we're going to put the line perpendicular to the construction line, so it's going to be touching C, so there's going to be no height for C, and then we're going to go for B, and then we're going to go for A, so we're going to follow A back to the edge view, first auxiliary, and then back two views, so we're going to go get a compass, put it on the line here, extend it up to A, and that will be our distance, and we follow the line back, put the compass on x2, y2, and we measure it out, and we leave it on, we mark it off there, and that'll be A. So then you repeat the process for C. So once we've this done, we now find our heights. Now all you have to do is join the dots. So we join a line from C to B to A and back to C. So there is the true shape of our lamina. And just to reinforce this now, we're just going to look at a quick augmented reality video of this. Here you can see we have the planes board, we have the true shape of our lamina, and now we'll be able to see the lamina as we move. So we can see, we'll put that top, that'll be B, if you can imagine now the x2, y2, so that'll be B, that'll be A, and that'll be C. So that's the lamina completely finished. And that is the true shape of the lamina here on the planes board, on the vertical and horizontal plane. And that's the end.